Hi, I will be going over 2.0 for real world simple interest. In this video, we will be going over simple interest, total of simple interest, compound interest, and continuously compounding. We're going to get started with simple interest. We use the formula I equals PRT when we're trying to work out how much interest has been earned. Okay, the parts of the formula, I represents the interest earned. P represents the principal. That's how much you start with, the dollar amount you start off with. R is the interest rate in a percentage form. T is time, and time is usually in years. Okay, so here's an example of simple interest. Charlene has $1,500 in her savings account. It has an interest rate of 4%. How much interest will she earn in 3 years? So here the principal, how much we start off with is 1,500. The R, the percentage rate is 4%. Remember, we take the percentages and we change it to a decimal by dividing 100 or moving the decimal 2 places to the left. So 0.04. And our time, T, is 3 years. So 3. So now we're going to plug those numbers into our formula. So it says PRT, P times R times T. So P is 1,500 times R, 0.04, times T, which is times 3. We're going to multiply those three together. We get 180. So she will earn $180 in 3 years at a 4% interest. Now let's take a look at total balance for simple interest. We use the formula A equals PRT plus P. So you can see here we still use that same PRT. So that's the amount of interest plus the starting value. So A is the total balance. We know what P, R, and T represent. So we're going to use that same example. Charlene has $1,500 in her savings account. It has an interest rate of 4%. How much will she have in her account in 3 years? This time it says how much will she have in her account. So it's asking for the total balance after the percentage rate. The previous problem says how much interest will she earn. Now we want the total balance. So we're going to use this formula. P, R, and T are still the same because we're using the same problem. So PRT, 1,500 times 0.04 times 3 plus P, which is 1,500. So we multiply these three, we get 180, and then plus 1,500, we get 1,680. So in 3 years, her account will have $1,680 in her account. So now let's take a look at this problem. We want to break this equation down. The equation A equals 750 times 0.045 times 4 plus 750. This represents the amount of money earned on a simple interest savings account. So let's break it down and see what each number represents. So what does the 4 represent? The 4 is in the T section, so that represents the number of years. So 4 years. What does the 0.045 represent? The 0.45 is the percentage rate. Remember, this it has to be changed to a decimal, so the actual percentage is 4.5% interest. What does the 750 represent? The 750 is the principal. We have it twice because we have P twice in the formula. Okay, now here's another question dealing with simple interest. Alexis took out a simple interest loan for $4,500. Interest will start accruing after 3 years. She wants the interest to be capped at $500. What interest rate is needed? So it says that she wants her interest, her total interest, to be capped at $500. And so we need to figure out what interest rate will do that. So first we need to find out what she wants the total to be capped at. So if she wants the interest to be capped at 500, we just add that 500 to the 4,500. And when we do that, we get 5,000. So she doesn't want to have more than $5,000 in there on the loan. So this time we're going to be using our A is 5,000 because she doesn't want to go over $5,000 for her loan. That is the total. Our principal is the 4,500 and T is 3. We need to find our R. So you see this time we plugged in a number for A. So our A is 5,000. So our P is 4,500. We don't know R. Our T is 3 plus 4,500. We're going to solve for R. So we want to start off multiplying 4,500 times 3. So 4,500 times 3 is 13,500 R plus 450. Now solving for R, we have to move this 4,500 to the other side. It's added, so we're going to subtract on both sides. When we subtract, the 4,500 cancels over here. 5,000 minus 4,500 is 500. And on the right side, we're left with 13,500 R. So now remember, you divide what's multiplied by R. So 13,500 is multiplied by R, so that's what we're going to divide. So divide both sides by 13,500. On the right side, they cancel out. When we divide 500 divided by 13,500, we get 0.037. That is our R. So remember, we need to change it to an actual percentage rate. So she needs an interest rate of 3.7%. You move that decimal 2 places to the right to get the actual percent. Now let's take a look at compound interest. Compound interest, we use the formula A equals P, parentheses 1 plus R over N, all to the power of NT. So with this problem, these simple compound interest, you have to pay close attention to what the N is. The N is the number of compounding periods in a year. So let's take a look at different type of compounds. So compounded monthly. If a problem says it's compounded monthly, there are 12 months in a year. It's going to be n equals 12. Compounded quarterly, there are 4 quarters in a year. So n equals 4. Compounded yearly, year is just 1 year. So n equals 1. Compounded semi-annually, that's twice a year. So n equals 2. Now, these are the ones that you'll mostly see in your problems, but we have a couple more. Compounded weekly, there are 52 weeks in a year, so n would be 52. Compounded daily, there are 365 days in a year, so n equals 365. So those are the different compounds. The ones that you will use the most are the first 4. You'll see a lot more compounded monthly. Okay, so let's take a look at this example. Kiara wants to invest $8,500 in a savings account with the annual interest rate of 6.25% for 5 years. What's the total amount if the account was compounded monthly? So here we using this formula. Our principal is $8,500. Our percentage rate is 0.0625. It says 5 years, so T equals 5. And it says compounded monthly, so our N equals 12. We're going to plug those numbers into the formula. So when we plug the numbers into the formula, this is what we have. Remember, you must pay attention to order of operation. With order of operation, the first thing is our parentheses. So in the parentheses, we have an addition and a division. Division comes before addition. So we must divide these two numbers first. So when we divide, and we can also multiply those at the same time, the power. When we divide the 0.0625 by 12, we get 0.005208. And I just rounded up to like 6 places. You don't want to round to 2 places. That will make your numbers off. You want to, basically, it's just kind of better to keep all those numbers in your calculator and not even round. 12 times 5 is 60, so our power is 60. Next, within the parentheses, 1 plus all of that. So you just take that, add 1. So we get 1.005208. Now, the power of 60. When it comes to the power button on your calculator, you should have a button that says X to the power of Y. If you use your cell phone, and you're using the calculator on your cell phone, if you turn your calculator sideways, it turns into a scientific calculator. And then you should see that X to the power of Y. It may even say Y to the power of X, but they're the same button. So now we're going to take care of the power. So when we take 1.005208 to the power of 60, we get 1.36573. And I rounded up to 5 places. Like I said, when you're working it out, just keep the numbers in the calculator. Then multiply it by 8,500. That's your very last step, multiplying it by the 8,500. We get 11,608.70. So the total balance will be $11,608.70. That's how much she will have in her account after 5 years if it's compounded monthly. Okay, so now let's take a look at the problem again. So we worked it out. We got $11,608.70. How much interest was earned? Well, if we want to figure out how much interest was earned, we're going to take that 11,608.70 minus the 8,500. We get $3,108.70. That's how much interest was earned. You may have some questions like that after you work out the total problem. So the account earned $3,108.70 interest in 5 years. So when you're dealing with compound interest, you want to work out the total interest first, and then if the question asks how much interest was earned, you minus it from the principal amount. So this different than simple interest. Now let's take a look at compound continuously. A equals P to E to the power of RT. Now on your calculator, you have a button that says E when it's scientific. So like I said, if you turn it to the side, you have a button that's E. Then you also have a E to the power of X. We want to use that E to the power of X. So here it says, and all you need here is the principal, the rate, and the time. So Kiera wants to invest $8,500 in a savings account with the annual interest of 6.25% for 5 years. The same problem as before. What's the total amount if the account was compounded continuously? So we're going to use this formula. So P is 8,500, R 0.0625, T is 5. So you can see here, 8,500 times E. We don't plug in anything for E. Then the power is RT, 0.0625 times T. We're going to multiply those two. So 8,500 times E to the power of 0.3125. So you're going to take your calculator and you're going to type in on most of them this number first and then E. It'll give you a number. Then you multiply it by the 8,500. So when we take E to the power of 0.3125, we get 1.36684. We're going to multiply that by 8,500. We get 11,618.12. So the total account will be 11,618.12. So you can see that working this out, as long as you understand that E button, it could be a little bit easier than a compound monthly, quarterly, yearly, those type of problems. So whenever you see compounded continuously, you're going to use this formula. Okay, so we're taking that same problem. Now we want to figure out how much interest was earned. So again, with this problem, we're going to take the amount the total amount minus the starting amount. So 11,618.12 minus 8,500. We get 3118.12. The account earned $3,118.12 interest in 5 years. Okay, now thanks for watching. If you need more help or you have more questions, please reach out to your teacher or check the tutoring options on the schedule to get that extra help that you may need.